Hey there, in this video I wanted to show a different way of creating an outline effect for something like a toon shader or really anything you want an outline around your mesh for. And typically what we would do is use a solidify modifier to create that outline. And that's good, and that is reliable, and it's quick, and it creates a really nice outline effect. But you can do a lot more with geometry nodes, and that's what we'll be building in this video. But first I just want to show kind of how this is typically done. So what you would do is add in a solidify modifier and set the thickness to something like maybe like that. And then we need to flip the normals and set our materials to an offset of 1. And then back in the material settings, create a new slot and a new material there. We'll call this solidify outline. And in here, what we need to do is change this to an emission shader, because anything like a principled BSDF or a diffuse BSDF, any shader that understands shadow information is not going to work because the normals are inverted. So we're actually looking at the back face of the mesh. And that's also why we need to tick on back face culling and then turn the shadow mode to none, so it doesn't cast a shadow on itself. And that's pretty much it. And we can change the thickness here, and that might really be all that you need. And this is a really nice kind of even outline over the mesh. And this is a great effect, and is really preferable for a number of options, especially if you don't need that outline to do anything else than this. But if you use geometry nodes to get that effect, let me turn that on over here, you can get pretty much the same effect, plus a lot more things are possible if you do it this way. Let me give you a couple examples. First is shadows. So over here, I have a point light up here and an object in the scene. And if I move this object around, you can see that on the solidify version, the emission shader, it can't understand shadows, so it won't be able to be occluded by any object between itself and the point light. So that's one. And you may not need that, but you might want that. And over on the geometry nodes version, you can see that this shadow information is taken into account with this outline. So it's able to understand, or at least give the effect of a shadow, and that's something that you might want. Another effect I can do with geometry nodes is kind of give this a little bit of a kind of a rim light effect. So I have this point light, or really any object that you can set as a reference object to where the outline can kind of create a rim light effect, or be sensitive to the position of any object. So that's another advantage. And lastly, and this is really where things get more interesting, is animating that outline in any number of ways. So here's just kind of one example of what things you can do with the outline itself, and even something like a little bit more crazy if you want. And that's just like another whole set of possibilities that geometry nodes opens up for you that you could never really pull off with, or at least it's a lot more difficult to pull that off with the solidify method. So, all right, so that's the difference. So let me show you how to go ahead and make this. Okay, I got a new scene here. I'm going to get rid of the default cube and add in Suzanne. I'm going to subdivide by 2 levels and shade smooth. And right away, I'm going to go to material preview. Make sure that I have scene lights and scene world in here. I'm going to add in a light, just add in a point light, give this some intensity. And I'm going to give this mesh just a base material. So let's just call this base. I'm going to go into shading and switch to scene and world lighting. And I'm going to just get rid of this principled BSDF. I'm going to add in just something super simple. So diffuse BSDF here, give this some more interesting color. Okay, something like that. Okay, now let's head over to geometry nodes, and I'm going to add in a new tree. Let's just call this outliner. Okay, and the first thing I want to do is basically duplicate this mesh. And we can do that a pretty simple way. We can just say set position. Here, I'm going to drop that in here, and I'm going to guide in this geometry down there, and then join it back up with a join geometry node here at the end. Okay, so I'm going to hook that up here. So now we really have two meshes, and I can offset one mesh by any amount. And what I want to do is kind of expand it out along the normals in the same way that the solidify modifier would be doing if we were doing it that way. So what we need to do is grab our normal. I'm going to plug that into the offset. So right now that just kind of balloons out in a crazy way. So we need to calm this down a little bit. So I can do that with a vector math set to scale. I'm going to drop that in right here. And now we can bring this way down to something a little bit more reasonable. Let's just set that to 0.01 for now. Okay, so now we mute this, we can kind of see the effect happening there. By the way, a great way to mute or to at least disable a connection is to use Control Alt and then right click and drag. So you can kind of turn connections on and off that way. You can also hit the M button on a node itself, but I find it useful to just kind of mute connections that way. Now, if we go into X-ray mode with Alt-Z, we can sort of see what's happening here. We can kind of see the effect of our scale. Let's bring that back to 0.01. So we've kind of already done sort of a solidify effect right here in geometry nodes. And we could just keep working here and make this tree really complex, but I think now is a good time to create a node group so we can create parameters to control this thing as we build it. Okay, so I'm going to grab all of these nodes in the middle. I'm going to hit Control G to group those, and then tab out of that to get back to our parent tree. So now we can see that we've encapsulated all those into a new node group, which I'm going to then call outliner, I guess, or I don't know, outline effect, something. All right, so now if we tab in, we can see the group details. So we have the group input node going in, doing a bunch of stuff in the middle, and then spitting out a geometry at the end. So that's basically what we have here. So we're going to be tabbing in and out of this node group a lot. So I want to create our first parameter here. So I think I want that to be just the amount of thickness that this kind of pseudo solidify effect has. So what I'm going to do is multiply the scale by some value that I'm going to send into the node group. So I'll do that by adding a math node in here, and I want this overall factor to be the one that we're multiplying. So I'm going to make that here and make sure we set this to multiply. So if I plug this node in here, nothing should change. It's still going to get 0.01 as the value. So I'm going to plug that in right there. And then this value here is the one that I want to control. So I'm going to send that into our group input. And this is going to be our first parameter that I'm going to call thickness. Okay, so thickness is going to be a multiplier of this kind of global multiplier that I'm sending into the scale of the offset. So if I go back out to our node group, I should see thickness here, and I should be able to control that through this node group parameter. Okay, I'm going to tab back in to see what we're doing. Okay, now just as we did with the solidify method that I showed you at the beginning of this video, we need to flip the faces there. So search for a flip faces node and drop that in right here. And I also need a separate material for the outline itself. So search for set material, and we'll add that in right about there. And I also want the material itself to be a parameter that we can easily control. So I'm going to send in the material to the group input, and let's just call this outline material. Okay, I'm going to go into material preview, turn on our scene world and lights. Okay, let's go into material here, and I have base, and I need to make a new material for the outline itself. So I'm going to create a new slot there and create a new material called outline. And here is where I need to do a little bit of work in the shader. So I need to change this to emission, and in settings, change the shadow mode to none, and then tick on backface culling, and blend mode to alpha blend. And now back in our geometry nodes tree, let's tab out to the node group. And here is where I want to pick that new material. So I'm going to pick outline, and we've made some progress. Now if I adjust thickness, I should see that respawning. Okay, so that's very good. Let's go back into the node group. So with this work here that we've done, we've pretty much reproduced that solidify outline effect that we started the video with. This is going to be the foundation on top of which we build in a lot of different customizations and possibilities that we can do from here on out. Okay, so the first effect that I want to create is kind of a rim light effect that is sensitive toward a point in space. So if this is the point, I want all the faces that are kind of facing that point to have an outline, and then the points away from it to kind of disappear. So to create kind of a rim light effect. Now to do that, we're going to first, let's first add, well, you know what, let's just use the light for our object. We'll use that as the point towards which we want the outline to be facing. So I need to get the information about this light or this point or this any object really in the scene. I need to get that into the shader, and we can do that with a node called object info. And here's another parameter that I want to set up. I want to be able to determine what that is from outside the node tree. And we're going to call this reference object. Okay, so let's tab out of the tree, and in this reference object parameter, I'm going to use the eyedropper to pick the point. Okay, let's go back into the node group. And now I have access to things about that object from within the node tree, things like location, which is what we're going to be using to tell the outline where to be facing. And the way we're going to do this is we're going to retrieve the relative location of this object right here, our light. Get back into our node group. I'm going to use the relative location of the object and use that to offset the position of the outline. Now we can see all the vertices of the outline mesh they're already offset by the normal that we've done here. That's how we get the thickness. But we actually want to move all of them in some direction. Okay, so we're going to do that with another vector math node. I'm going to drop that in after this happens, and I'm going to set this to add. And I'm going to send in the location into that vector. Now, wow, that really moves it quite a bit, but it's moving it basically the distance of the relative distance between all the vertices in this mesh and the object that we want it to move towards. So if no matter where I move this, it's just shifting all the vertices towards that point, or actually to the location of that point. I'm going to reset the location here. Well, I don't want to move it the full amount. I want to just move it some partial amount. So I'm going to scale this back. I'm going to do that with some multiplier. So I'm going to add in, I'm just going to duplicate this vector math node, set this to multiply, drop that in just before this happens. And now I can see that things are definitely back to where they were because I'm multiplying it by 0. So it's not moving anywhere. I just want it to move a little bit towards that location. So instead of multiplying this by some other vector, I could set this to scale. And now I can bring this way down something close to 0. So I'm going to say 0.01 is pretty good. So this already now kind of achieves what I want. So I'm able to move this source around, this light source or this object around anywhere. And the outline is offset by a little bit towards that point. So that's pretty good. But really I want to control the degree to which that offset happens. So I'm going to call this another parameter. So just like we did with the thickness, I'm going to add another multiply node and bring this into the scale. And I'm going to call this second value another parameter called offset. Okay, so now if I go back out to the node group, now I have an offset here. So I can change the degree to which, or the amount towards the reference point. Okay, I'll tab back into the node group. So this already is pretty powerful and it does some useful things for us. I'm going to set these back to 0 for now so we don't see any effect really at all. So one little bit of housekeeping is I want to be able to control these parameters here that we've set up in the node group. I want to be able to do that just from the geometry nodes panel without having to go into geometry nodes and mess with the tree and all that stuff. So we need to hook this up to our group input here. So I'm going to hook up all these different things just like this. And now you can see that they're exposed now in the geometry nodes modifier panel, which is really convenient. So now I can be really anywhere and I don't have to see the geometry nodes tree, and I can go in here and add an offset, change the thickness, and pick a reference object and assign the material and all that stuff without having to go into the node tree itself. Pretty cool. All right, but let's go back in here and do some more work. I'm going to tab back into the node group. Now, what if we wanted to, let me give this an offset again. Now, what if we wanted something to cast a shadow, or at least give the effect of casting a shadow into an area that is obstructed by some object? So we really can't do that with an emission shader because well, emission shaders just don't care about that, or they're unable to understand that. So how are we going to actually achieve something like that? This is a great opportunity to use the raycast node. And the raycast node it's a little bit intimidating looking if you haven't used it before, but I promise you we'll demystify it here. It's not that scary. But basically what we're going to do is imagine a point up here that we're using in the node tree here. This is the object that the light is supposed to be pointing towards. And we're going to have basically each vertex on the surface of our object that we have the outline applied to. We're going to tell it, hey, look in the direction of this point here. Look straight towards it. We're going to do that with every single point on the mesh. And we're going to tell this point, hey, if you can see this point, if you have access to it, then you're illuminated. But if there's an object here that you run into, or that your line of sight is interrupted by something, then guess what? You're in shadow. So don't show the outline there. That's basically what we're going to be doing. So we're going to bring in a raycast node. Just going to drop it in right above here. So first, let's tell each point on the surface of our mesh which direction they should be looking into. Should they be looking that way? Should they be looking this way? Like where are we looking at? Which direction are we firing rays off to? And that's what ray direction really means. So we need to provide that direction for each of these points. How do we do that? Well, we know the location of each of these points, and we know the location of the source light. So we need to get the relative direction here, and we can get that from subtracting the location of the light, which is basically a vector, and the location of each point. I'm just going to use this one as an example. We need to get that vector. So all we need to do is subtract this vector by this vector, and we get that. So that's what we will do. So let's do a vector math node. Let's drop that in here, and let's get the position. And let's subtract the position from the location of our point light up here. We're going to send that into ray direction. Nope, we need to set that to subtract. And the other necessary input to the raycast node is the target geometry. And this really is saying, what geometry do you care about the rays hitting or not hitting? That's really what that input is for. Well, we don't have anything yet because there's nothing between here. So let's put something in there so that we can test against. So let's add in a UV sphere. Let's move it up. I'm going to scale this down just a little bit. So you can kind of see, right? It's got a shadow on the base material because it understands shadows. So we're seeing a shadow there. But the outline does not understand that. So this is what we're going to be solving, hopefully. So let's go back to our node tree. So let's try bringing in another object info node. And let's pick this object here. And let's send in the geometry into raycast. And let's actually set this object info to relative. Okay, so what have we done here? We're saying for each point, cast a ray off in this direction and test that ray against this object and see if you hit it or not. Okay, that's what we've done. So what we can do from here on out is actually delete the geometry that has a positive hit result. So let's add in a delete geometry node, and we want to delete geometry from, this is our outline mesh here, this bottom kind of tree. And this straight line here is just the purple original Suzanne mesh. So we want to delete it right there. That's where we want the deletion to happen. And isHit is going to tell us if that ray hit something or not, or not something, hit this specific object. So we're going to say send isHit into the selection for the delete geometry. Okay, and that's kind of how we get this this effect here. Now you can kind of see that does work. This actually might be fine for what you need, but the first thing I'm concerned with is this object info node set to this sphere. Okay, I don't want to have to do that for every object that might cast a shadow or not cast a shadow. So for example, if I had two spheres, then one of them is casting this shadow and the other one isn't. So that doesn't work. So how do I fix that problem? Well, first step that we can do there is instead of using object info, I'm going to use collection info. And then in my scene, I'm going to create a new collection called shadow casters. And I'm going to place the sphere into shadow casters. Okay, and I'm going to change this target geometry to my collection info. And I'm going to pick shadow casters, pick relative, and then finally add a realize instances node to make that geometry kind of quote unquote real as from the perspective of this node tree. Okay, so now I can duplicate this thing here and really affect the whole mesh in its entirety. And I don't have to do this each time for every object. All I need to do is make sure that things I want to cast shadows over this particular object, just make sure that they're contained in a collection called shadow casters, and the rest is automatic. Okay, so now let's make sure that we're making our parameters as we go. So let's send in this collection info to the group input, and we'll call this shadow collection. Okay, and we'll tab out. And let's also send that parameter further out to the group input for the geometry nodes tree in general. So now we have that parameter available in the geometry nodes panel here on the modifier level. So that's, I want to make sure we keep doing that. Let's tab back into the tree and see what we have. Okay, let's add one more parameter for to give us an option if we even want this effect in the first place. So let's add in a Boolean math node, and we're going to send that in. We're going to interrupt this is hit result from the raycast node. We're going to send it right in there, and this is going to basically say, do we want this effect to happen or not? So we can send this now to our group input. I'm going to call that enable shadows. Let's tab out and forward that on. So now we have enable shadows option. Pretty cool. Okay, so let's enable shadows here just to take a look at this one more time. Now, what if I wanted the shader, the white emission shader, to really kind of not be totally gone? Like, what if I wanted some different color in here other than white? Well, I can't do that because I've deleted the geometry entirely. So there's nothing here to shade. So this is an option to create the effect, but it's a little bit it's destructive and limiting. So because we can't do anything to this part of the rim lighting, even if we wanted to, because it's not there. So how do we provide this shadow information to the shader itself, to the outline shader? We can use attributes to do that. So the node to do that is, let's go over here. I'm going to disable this delete geometry just for now, and add in a capture attribute node. I'm going to drop it in right there. And I'm going to send in the results of our ishit into the value. Again, the domain for this value is not a float, it's a Boolean. It's either hit or it's not hit. I guess I have to do that again. So I'm going to send that in there. So this outgoing socket here from the capture attribute node stores the value of that attribute. And I want to output that attribute to the group itself. So let's call this is shadow. Okay, let's tab out and make sure that we expose this fully to the group output. And in here, so output attributes. So now we can see that it's visible, or it's the node, the geometry node's modifier it's aware of this outgoing attribute, so it has some value. But we need to assign it a variable, so we'll just call this is shadow. Okay, so now this variable is exposed and can be seen by the materials used by this object, which is great because I can go into the material for the outline. I'm going to go into shading here. Okay, and I can bring in a node called attribute, and it's going to be from the geometry, and I can use that to create some effect here. And the most basic thing I probably want to do is to mix that in with a transparent shader. So I'm going to bring in a transparent BSDF and add that in here. And remember, we called this attribute is shadow, so we need to provide the attribute node with that name. And I think factor is probably going to be what works, but I'm going to try to use color as the factor for the mix shader. Sure enough, that works. Okay, so this is really great because now what we can do is mix in. Let's see, we want to mix white, I think, right? So let's. Or do we want to mix black? Yeah, we want to mix black. So we can sort of govern the level of shadowness or transparency that this mix shader is using for its factor. So this is pretty cool. So we can even give this a different color, or really, you can do whatever you want now in here because we have the ability to understand where the vertices are that are kind of in shadow. So this is a little bit more powerful of an option if you want to do it that way. Okay, let's go back to the node tree that we have built. So a lot going on here. So all this stuff above here is the shadow generator. So let's just group that together. Let's just join that with Control J and rename this. Just call it shadow, I guess. Okay, now in this last section, I want to show you how to do some effects on the shadow itself, or not the shadow, the outline. And we're going to kind of do that in here. So we have our material all assigned. So by this point, we have a bunch of stuff kind of happened along the way here. We set the position, we offset the outline, we flipped the faces, we gave it a material, we provided an attribute for where the shadow is. We've done a lot during the course of this this kind of section of the tree, but in here I want to do some more interesting stuff, like animate them around and things like that. So we're going to do that with another set position node. I'm going to drop that right in here. Let's pull this down so we have some clear working space. So at this point, we can still move things around. Right? We can kind of still manipulate this. So we can kind of just play around here a little bit. So why don't we start by adding in a noise texture. Put that in here, and we can sort of see just right away if we plug that in there, just like chaos happens. So we don't really want that. But the first thing we notice is that it's kind of all moving in this direction, in the positive. It's moving in the positive X, the positive Y, and the positive Z rather, and the positive Y directions. It's all kind of like being offset diagonally. And the reason why it's doing that is because all of these color values coming out of here are values of 0 to 1 on the X, Y, 0 to 1, and Z, 0 to 1. So it's all kind of pushing it away. So we want to remap these values to so they're kind of equidistant from 0. And one way to do that is to add in a vector math node here. Let's subtract from all of these values 0.5. Okay, so that'll bring everything kind of in right around 0. And let's add in another vector math set to scale so we can kind of just control the intensity of this effect. So maybe right around here, let's make the scale of the noise a little bit less. And to animate this, there's a bunch of ways to do this, but an easy way is to just make this noise texture 4D. That gives us access to a W value that really just kind of shifts the noise. It's like basically like a seed value for the noise. So if we shift this value, it kind of animates the texture. So let's bring in a scene time, and let's divide this. Let's see. Let's divide the seconds by something to slow things down a little bit, and then send that value into W. So now we can make things move. So that's a little bit slow, or maybe the texture isn't interesting enough. Maybe, yeah. I mean, here it's kind of up to you what you want to do. But that's how you animate things generally. And we can even use some other type of texture. Actually, let's add a Voronoi texture in here. Let's bring this to 4D. Send the scene time in there. Let's maybe use color for this. We can do the same subtraction, and let's duplicate the scale. Let's use this instead and see what we got. So that's kind of even a crazier thing. Change our offset. Make things a little bit more towards the object reference. We can still move this around and things still change. So really, at this point, it's whatever you want to do down here for the effect that you want, you can go ahead and do that. So let's group this together and call this animations. So just experiment and have fun with that down there. So yeah, that's it. If you want, you can bring in another group input node, and let's see, send in the scale. Let's add in a math node set to multiply, and we're going to do the same trick that we did earlier, 0.01 or 0.1 maybe, and add in this value to our group input, and let's call this animation intensity or something, whatever you want. And let's make sure that we bring that on out to the geometry nodes panel. So now we have kind of an intensity scale for the animation. Let's make this outline. Let's make this like super intense, maybe like a 10. Right? Just have fun with it. So these are some of the reasons why you would want to use geometry nodes to create your outlines versus something like a Fresnel or the solidifier modifier that I described earlier. So it's a lot more powerful. It just enables you to do so much more. So that's it. That's all I wanted to show you. Let me know if you like this video or how I can improve these for you. And yeah, that's it. Thanks for watching.